Hi everybody, Morgan here. So we're going to be talking about roadmap problems today. And this is going to an expanded roadmap from what we were using before. Previously we just had molecules, moles, and mass. But now what we're going to do is we're going to expand and we're going to have molecules, moles, mass, and the volume of a substance A. Now mass to volume questions we did in our first unit, that's density. Okay? But we're also going to add a second road here, which is substance B. Now we can go between the moles of A and the moles of B, the molecules of A and the molecules of B, by using the balanced chemical equation. All right, so the idea here is a mole ratio. That's what some people like to call it, okay? And that's how the moles within a chemical reaction align with each other. So let's look at what we mean by that. Let's balance this equation. I'm going to put a 2Na, a 2H2O, and a 2NaOH. There's my equation. How many moles of NaOH are produced by 1.00 moles of H2O? So 1.00 moles H2O. Times. Now, to go from the moles of A to the moles of B, moles of water would be moles of A, moles of NaOH would be moles of B. I look at the equation here, and I've got a 2 in front of the water. So I put 2 moles of water downstairs, and I got a 2 in front of the NaOH, so I put 2 moles NaOH upstairs. Moles cancels moles. Okay, 2 over 2 actually divide out, and this equals 1.00 moles of NaOH. So what we say is that this is a 2 to 2, or reduced, a 1 to 1 mole ratio. Okay, 2 to 2 reduces to 1 to 1 mole ratio. Now 2 to 1 mole ratio. You start to get the idea here. And that is the step that takes us from the top road to the bottom road. Okay? How many moles of H2 are produced by 1.75 moles of Na? So I have my 1.75 moles of sodium times downstairs 2 moles of sodium. And then upstairs I put 1 mole of H2. Because there's a 1 there in that equation. There, and this ends up being 0.875, if I'm doing that right in my head. Yeah, that's right. 0.875 moles of H2. Okay, so that's mole ratios and how we do the mole ratio homework. Let's go on now and expand so that what we're really doing is going from the mass of A to the moles of A, to the moles of B, to the mass of B, a 3-step problem. Here's our second reaction. We balance it by putting a 2 there. If you need to put 1s there to feel comfortable, be my guest. Now we start with 10.00 grams K2O times 1 mole of K2O. And to go from mass to moles, we divide by the molar mass. The molar mass of that compound is 94.20 grams of K2O. Now from the equation, 1 mole of K2O produces 2 moles of KOH. And 1 mole of KOH has a molar mass of 56.11 grams KOH. That cancels, that cancels, that cancels. And when I ran that through my calculator, I got 11.91 grams of KOH. Okay. And we're going to be doing a lot more problems that look just like that one. Okay. Based on the same reaction, how many grams of water are needed to completely react with 75.00 grams of K2O. So 75.00 grams K2O times 1 mole of K2O is still 94.20 grams K2O. 1 mole K2O. This time we're looking for water, so it's 1 mole of water. That's from up there. And 1 mole of water has a molar mass of 18.02 grams of water. So those cancel, those cancel, those cancel. And I got 14.35 when I put that through my calculator. Okay. So there you go. That's page 10. All right, let's move on to page number 11 at this point. We have a new reaction, CH4 plus O2, so we got to put a 2 there. We got to put a 2 there. How many grams of CO2 are produced by burning 32.0 grams of CH4? There you go. One mole of CH4 is 16.05 grams of CH4. 1 mole CH4 gives me 1 mole of CO2. That's the one that's here and the one that's here. The 1 mole of CO2, molar mass is 44.01 grams of CO2. That can cancel, that can cancel, and that can cancel. And my calculator said 87.7 grams of CO2. All right. Now another one based on that same reaction. We have 16.00 grams of O2. How many grams of water are produced by burning it? So we start with our 16.00 grams of O2 times 1 mole of O2, MOL, is 32.00 grams of O2. Then I can say 2 moles of O2 give me 2 moles of water, and 1 mole of water is 18.02 grams of water. Okay. Cancels, 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 and this equals 9.010 grams water if I'm paying attention to sig figs. All right. Now, let's go to a different reaction. Really neat one. Balance it with a 2, a 3, and a 2. So I have 100 grams of KClO3. How many grams of O2 were produced? So 100 grams KClO3 times 1 mole KClO3. Now the molar mass for that is 122.55. Then I can say 2 moles of KClO3 give me 3 moles of O2. And 1 mole of O2 gives me 32.00 grams of O2. These cancel, and those cancel. And on my calculator, 39.2 grams of O2. You see, we're following a basic algorithm here, doing the same thing every time. That's okay. I want you to get used to it. I want you to get comfortable doing it. How many grams of KCl are produced by the decomposition of 100.0? I just changed the sig figs up there. Now, again, 1 mole of KClO3 is 122.55 grams of KClO3. 2 moles KClO3. Now this time we're looking for KCl, so 2 moles of KCl. 1 mole of KCl has a molar mass of 74.55 grams of KCl equals, this cancels, that cancels, and I get 60.83 grams of KCl. All right, now what I'd like you to do at this point is to actually pause the video and try the next 2 problems on your own. Okay? See how you do with those. Okay, welcome back. So 2 HGO for 1 O2 and 2 HGs. I have 100 grams of HGO times 1 mole of HGO is 216.59 grams of HGO. 2 moles HGO. We're looking for O2, so it's 1 mole O2, 1 mole O2, 32.00 grams O2 equals, those cancel, those cancel, those cancel, and I got 7.39 grams of O2. Now for this last one here, I have 100.0 grams HGO, just playing around with sig figs a bit here, okay, times 1 mole of HGO is still 216.59 grams of HGO. 2 moles HGO give me 2 moles of HG, and 1 mole of HG has a molar mass of 200.59 grams. And I got 92.61 grams of HG when I ran that through my calculator. Okay, that's pages 10 and 11 of the lecture outline, and we'll be tuning back in shortly for page 12. All right, thanks for tuning in. Everybody have a good day.